All right, so today we're going to continue talking about tax policy. Before I start, though, I just want to note that we have a couple of journalists in the room. There are going to be some photographs during the lecture, just FYI. So to remind you where we left off at the end of the last lecture, we talked about how economists think about optimal income taxation. In particular, we were focusing on the rate at which we should tax people at the top of the income distribution. So tax rates on the top 1%. And we worked through the logic of the Laffer curve and trying to evaluate the extent to which people start to work less as you raise income tax rates. And where we kind of ended up was summarized by these two articles in the media by Peter Diamond and Emmanuel Saez, who note that high tax rates won't slow economic growth on the basis of the type of evidence we discussed in the last lecture. And they argue that if you want to maximize revenue, you could have tax rates of somewhere from 50 to 70% to maximize revenue taken from the rich. And then that got picked up by Alexandra Ocasio-Cortez, who suggests a 70% tax for the wealthy. So what I want to do to start today's lecture is pick up from that point and ask whether we can conclude, based on the analysis we talked about in the last lecture, that the optimal or the correct tax rate on top incomes is actually 70%, right? So I think what we see in the data is that the impacts of tax rates on labor supply are sufficiently small. That is, we have an elasticity of labor supply with respect to the wage rate of something like 0.3. So a 10% change in wages changes the amount people work by about 3%. And that relatively small response implies that the revenue maximizing top income tax rate may be as high as 70%, right? But does it follow from that empirical statement that the correct tax rate on high income families is 70%? So I think that's not necessarily the case for two reasons. First of all, notice that this calculation that we talked about is purely about maximizing revenue, right? So it's putting zero weight on the welfare of people at the top of the income distribution. It's saying that their income and their consumption doesn't enter social welfare at all. And if our goal is simply to raise as much money as we can from the rich, then we want to have a tax rate of maybe up to 70%. Now, of course, that's kind of an extreme view, that we put no weight at all on the utility of the rich or the income of the rich. So hard to imagine that people would literally take that extreme perspective. Moreover, and I think the second point is the particularly important one, it's not actually clear, I think, that the average American places a very high value on equity of incomes, even in the face of the tremendously high level of inequality that we see in the US today. And so to illustrate that, I want to talk about a study that was done recently by Ilyana Koziemko at Princeton and various colleagues, including Stephanie Stancheva, my colleague here at Harvard, where they measure preferences for redistribution systematically using online surveys of about 4,000 Americans. So the way they do this is using Amazon's Mechanical Turk platform, which is a platform that you can use to conduct surveys and get people to complete small jobs. So they get a bunch of people to participate on this platform. And they do two things. First, they just ask people about their preferred tax rates on people in the top 1%. So very much like we did a poll in this class in the last lecture, what do you think the tax rate on people in the top 1% should be? And the median in this class was a tax rate of around 50%, with a number of people preferring tax rates of 40%, 60%, up to 70%. Similarly, they asked exactly that question to the survey respondents. And then they evaluated the impacts of providing information about inequality on preferences for redistribution using a randomized experiment. So specifically, they took 2,000 of these 4,000 people, randomly selected, and they gave them information about trends in inequality and the effects of taxes on economic growth, much like what I've summarized in this class, but trying to do it in a simple way that people would be able to understand quickly. So just to give you a flavor of what this looked like, as people were doing this exercise online, they came to a screen like this, which first gave them some information about where they themselves fall in the income distribution. So they asked people to input their own household income. So let's say you put in $25,000. Then they tell you 39% of US households, given the actual data, earn less than your household. Okay, so you're doing better than 40% of Americans in terms of income. They then give you some further information about the distribution of income in the US using the slider where you can see how many people earn below $75,000 a year, $100,000 a year, get a sense of how much inequality there is. So that's the first set of information. Second, they show you some information on how inequality is changing over time by basically asking, where would you have fallen in the income distribution had inequality changed differently? So they say income inequality has increased dramatically in the United States since 1980. The incomes of poorer and middle income families have grown very little, while top incomes have grown a lot. How would you be doing if inequality had not increased? So suppose we had had uniform growth of wages across the income distribution. Given where you fall in the income distribution, how much would you be earning today if growth had been equally shared over the past 35 years across the income distribution? In this particular case, a household making $25,000 a year would actually be making $35,000 today if they had benefited as much from the economic growth that occurred over the past 30 years as higher income households did. Okay, so that gives you a flavor of how inequality is changing over time. And then the third piece of information they give is about the correlation between taxes and economic growth. So they basically try to convey in simple terms that increasing the federal income tax rate on very high incomes can potentially raise tax revenue without hurting economic growth. So as we've talked about in the last lecture, there's a substantial evidence base behind that claim. They try to convey it in simple terms here using this graph. I'm just going to zoom in on that, where they show how average incomes have changed in the United States. And they divide that into 3 periods. A period where you had very low income taxes on the top 1% before 1933, where you can see that if you just look at the plotted series, average incomes did not actually go up very much at that time. Then you have a period between 1933 and 1980, before the Reagan administration, where you had, as we saw in the previous lecture, fairly high taxes on top incomes. And as you can see here, you had quite a substantial growth in income over that period. And then if you look at the recent years, since 1980, you've had a reduction in top tax rates, but you haven't seen as much income growth. So the simple argument they try to make, just based on this correlational analysis, is there's not necessarily that much of a link between taxes and economic growth. Okay, so that gives you a sense of what the treatment is here. We're basically trying to give people information about changes in inequality and about the link between taxes and economic growth. And the question is, does providing this information meaningfully change people's perceptions about inequality and change their preferences in terms of top income taxation? So let me first address the first of those two issues. So what they're showing here is the fraction of people who, after they saw this information, if they were in the treatment group, responded to the question, is inequality a very serious problem, by saying yes. Okay, so the control group here, shown in the bar on the left, they didn't get any of that information that I just showed you. And you can see that about 30% of Americans think that inequality is a very serious problem just in the baseline. When you then give them that series of information that I just showed you, that 30% increases to about 40%. So it's a fairly substantial change, like a 1/3 increase in the fraction of people who think inequality is a very serious problem. So you can see, the way I look at this chart is people are paying attention, at least some fraction of people change their views about whether inequality is a very serious problem in the face of this information. But the key result from this study is if you then ask, what is your preferred tax rate on people in the top 1%? There are 2 key findings here. First, if you just look at the control group, the bar on the left, you can see that the average preferred tax rate on the top 1% for Americans as a whole is 30%. So much lower than the average we saw in this class. I think that might be consistent with your intuition that college students tend to be to the left of the average American. And so you see that borne out here. But then second, And the key result of this paper is even when you give all this information about inequality and the idea that taxes don't have that much of an effect on economic growth and so forth, if you look at what that does to people's preferences for tax rates on the top 1%, there's a tiny increase. It's almost imperceptible. There's a 1% increase in the preferred tax rates on people in the top 1%. So the way I interpret that is that even when it's very clear to people that there's a lot of inequality in income, that taxes don't have very big negative effects on economic growth, there's not a tremendous amount of support actually for greater equity in incomes. Lots of people in the US think it's perfectly fine that you have a lot of inequality. Maybe if you made a lot of money starting a successful business, being an inventor, whatever it is, perhaps you should be entitled to keep that money. And it's not obvious that a lot of people feel that we should have redistribution, highly progressive taxes to reduce the level of inequality. Questions on this study before I move on? Yes. Good question. So I think you find a smaller link than you might expect. I don't know if this particular study explored that because you have a specific set of people who participate in these online surveys. It's not going to be incredibly wide across the income distribution. But more broadly in this literature, what you find is even people who are at the low end of the income distribution, you might think if you're just responding in your self-interest, if you're at the bottom of the income distribution, you might want to have very high taxes on the rich, right? But that is not actually a very strong pattern in the data. There's not a strong link between people's preferences for progressive income taxation and their own incomes. That might be surprising, but that's a strong feature of what you see. Yeah? Stephanie Stancheva, my colleague, is actually currently conducting similar studies in European countries and so forth to try to understand how these perceptions vary across places. And my sense is they do differ in pretty significant ways. There's more support for redistribution in Scandinavian countries, in European countries. And she's trying to understand, why that's the case, what the drivers are of these perceptions and preferences. Great. Anybody else? Okay, so let me summarize where I think and take stock of where I think we stand on income taxation. So recall that the way economists think about tax policy essentially thinks about the trade-off between equity and efficiency, right? We weigh the benefits of greater equity from higher taxes on the rich against the efficiency costs, the fact that people might work less, that there's less economic growth. So what do I think we can say from the data when people ask me, what are my views on tax policy and taxing the rich? I think you can say based on modern empirical evidence that the efficiency costs of taxes are relatively modest. Taxes on the top 1% can be sort of safely increased without some dramatic reduction in economic activity. Now, obviously, there's going to be a limit to that. If you have taxes of 80 or 90%, at some point, people might decide that they don't want to work as much. But in the range where we are, tax rates of 35, 40, 45%, I don't think there's strong evidence that tax changes in that range have dramatic effects on the amount people work or business creation, things like that. But whether that empirical fact means that we should have high top income tax rates, I think fundamentally goes outside the domain of traditional economics. It depends upon value judgments about the importance of equity. And that's something that I think people have different opinions on. My own sense, my own reading of people's perceptions from the type of study I just described and more broadly is that there's probably broader public support, especially in the United States, coming back to the question about differences across countries, for equality of opportunity rather than equality of outcomes. That is to say, when people see lots of different realizations of outcomes, that some people happen to earn a lot of money, other people don't, they seem less troubled by that, at least on the face of it, than when you have inequality of opportunity, as we talked about in the first half of this class, where your life chances are greatly determined by the family into which you're born, for instance. And I think that could potentially explain why we're seeing the patterns that we see in terms of tax policy in the United States at present. Okay, so any final questions on the basics of the income tax before we move on to the next segment? Yeah. Yeah, I don't know, I can't recall if they collected information on race specifically, but they do a lot of subgroup analysis, like looking across different parts of the US, looking across, cutting the data in various ways, and you find pretty robust patterns. You rarely find substantial support for high tax rates on the rich. I think that's a pretty systematic pattern, actually. Yeah. Okay, great. So in the rest of this lecture, I'm going to shift gears slightly, but talk about a related set of issues that illustrates the frontier, I think, of the literature on taxation in economics. And so this is the field of behavioral public economics, or behavioral economics and public policy. So the traditional economic approach, if you were to take Ec 10 or one of the standard economics classes, most of what you'd learn starts from a very simple model where we assume that all individuals are fully aware, in this case, of the taxes that they're paying, and optimize perfectly in response to the incentives they face. Okay, so people make decisions that maximize their utility, perfectly taking into account all of the different trade-offs. Now, is that fundamental assumption, which is really the core of where economics has started from, is that true in practice? So let me ask you to just introspect about a couple of questions. So do you, for instance, know what your marginal income tax rate is? Exactly how much you will end up paying to the government if you earn another dollar? Do you think about it when you are deciding to take an extra job, maybe an internship or something like that? Are you focused on marginal tax rates? And when I say marginal tax rates, really the right way to think about it is not just the amount you pay to the federal government today, but potential benefits you might get down the road, for instance, in greater Social Security benefits if you're contributing more in terms of Social Security taxes. So it's actually, there are a number of things involved beyond literally calculating your federal income tax rate. Or, in a different context, do you think about it if you're thinking about whether to contribute to an individual retirement account? So you can introspect on those questions. One thing that I think led me and many others in this field to think that maybe people aren't thinking about these issues perfectly accurately is just the sheer complexity of the tax code. So if you look at what marginal income tax rates actually look like in the US, this is for one particular case, a single head of household who has 2 kids in 2006, so just picking one example here. This is plotting what your marginal tax rate on income would be as a function of your pre-tax earnings. So remember, marginal tax rate refers to when you earn $1 more at a given income level, how much do you give to the government? So notice that this moves around tremendously. So initially, the marginal tax rate is negative. Why is that? Because of the earned income tax credit, which we talked about before, where the government is paying you as you earn more money. Then it becomes very high. You actually face your highest marginal income tax rate around an income of $35,000 or $40,000. Why is that? Because these programs like the earned income tax credit are being phased out. You're losing eligibility for them as you earn more, so effectively you face very high marginal tax rates. And then you can see that it moves around and then eventually stabilizes at the high end around a marginal tax rate of 38%. So a person who's fully rational and abides by the traditional principles of economic optimization should know this schedule perfectly. And then moreover, if you're earning $37,000, you should recognize that the marginal tax rate is 51%, but if you're earning $43,000, that it's down to 30%, and accordingly take an extra job or make decisions about retirement savings, which are going to be exempt from these taxes accordingly. Now you can imagine that that might be quite difficult to do. Just even keeping track of exactly what the schedule is probably difficult. And then moreover, figuring out how you should respond to it is another challenge. A different sort of more mechanical way to see the level of complexity is just the sheer length of the tax return. So look at the number of pages of instructions that come with the Form 1040 tax return. up to 207 pages in 2013. I doubt most people are reading those 207 pages. And so again, it calls into question whether people are actually optimizing with respect to the tax system. So what I'm going to do in the rest of this lecture is give you 3 examples of how we have seen these issues of lack of information, awareness, behavioral public economics considerations, how they play out in terms of responses to tax policy and how they might change how we want to design tax policy going forward. So I'm going to start with an extremely simple example, sort of the simplest example you might think of, sales taxes on purchases in grocery stores. So forget about the complexity of the progressive income tax schedule that I was talking about. Let's just make it even more plain vanilla. Just the sales tax you might all be familiar with. When you go to the grocery store, you pay 7% extra at the register for many things that you buy, right? So in a paper we wrote back in 2009, we test whether consumers are aware of and respond rationally to simple sales taxes. So key feature of sales taxes, relevant for what I'm going to show you here, is that, as I'm sure all of you know, sales taxes are not included in posted prices in the US. So this is different from European countries where a value-added tax would typically be included in the price that you see on the shelf. In the US, if you see a product for $5 on the shelf, you're actually going to pay something like $5.25 when you check it out at the register. So we test whether the fact that sales taxes are not included in the posted price, whether that affects the response to sales taxes using first an experiment in a grocery store in Northern California. So the idea here, the premise, is that the rational economic model would predict that it's totally irrelevant that sales taxes are not included in the posted price, right? If you're optimizing perfectly, you should know that there's going to be 5% or 8% added at the register, and you should take that into account when you make purchasing decisions. The behavioral view might be that people are inattentive and maybe they don't pay attention to these taxes because they're not included in the posted price. So we go about testing that. We went about testing that in an extremely simple and somewhat crude way, where we managed to partner with a large grocery chain in Northern California and did the following experiment. So we took the pre-tax prices that you'd normally see on the shelf, so the original tag, for instance, for that hairbrush in the upper right, $5.79, and we tell you what the price actually would be once you include California sales tax. Total price $5.79 plus sales tax equals $6.22, okay? So we did this for about 1,000 products back in 2006. I actually remember, I think Greg Bruich helped do this study. Greg was an undergrad at Berkeley, if I remember, at that time. I was an assistant professor at Berkeley. So we went up to this grocery store at midnight, and I remember printing these tags and putting them up on these 1,000 products. And you might wonder, why are we focused on this set of hairbrushes and stuff like that? So when we first made the pitch to the grocery store that we want to test this hypothesis, their reaction was, absolutely not. We believe your hypothesis that people are going to buy less as a result of this intervention, and we don't want to let you do this. But what we settled on was we're not going to tax their kind of high revenue products. We're not going to do this with the things that drive the volume of purchases. Instead, we're going to focus on things like hairbrushes and a set of cosmetic products, which are less important for them. They're also quite useful from a research perspective because they're what the store calls impulse purchases, meaning they're very price elastic. So if the price changes by $1, people are much less likely to buy these things. And that's very useful, right? Because if you did this with something like milk, where the elasticity of demand is going to be very low, you're going to have a hard time figuring out whether your intervention actually did anything. Whereas with these types of products where people are very sensitive to price, showing people taxes might actually have an impact, okay? So that was the intervention. We had a set of products that we put these tags on. And then we had a set of control groups. So there are other products in the same aisle where we did not do this intervention. So think about shaving products or other things that might have been nearby. There are other stores that we identified before the experiment as being similar to this store, run by the same chain, that we think of as control stores, where there was no intervention. And then you can do a pre-post comparison. So we did this intervention for 3 weeks in early 2006. You can look at the time period before we went into these stores, okay? And so to show you what the impacts are, I'm going to turn to this table here. So this is going to be a simple difference in difference type of analysis. Should be familiar to you from other applications of this method. So here we're looking at data on the number of units sold in the treatment store per category. So they classify products into different categories. So there might be the cosmetics category, hairbrushes, et cetera. And so if you take the number, for instance, on the upper left, that tells you that before the experimental period, in the control categories where we did not do this intervention, they were selling 26.4 units on average, so 26.4 razor blades or whatever it is in each of those categories. And so then you see the data for the control categories on the left, the treated categories on the right, in the baseline period before the experiment, and then during the experimental period. And so the way we think about the data here is first focus on the treated category column. We see that the number of units sold of those treated categories fell from 25.2 to 23.8. So we see a reduction in sales during that period. So that seems consistent with the view that perhaps showing people these taxes reduced the amount they wanted to buy of these products. But as we've talked about in other settings, anytime you do an intervention like this, you also need to account for the fact that other things might have changed between the baseline period and the experimental period. So what's a good example in the case of grocery stores? There's a lot of volatility in demand and a lot of variation in foot traffic across weeks. So to give you one example, you see a huge spike in sales of soda around the Super Bowl, and you see a lot more people in grocery stores around the Super Bowl. So if you were to just do a comparison of data after versus before the Super Bowl, you're going to see fluctuations just from that fact, right? So to account for that, you can compare to what's going on in the control categories. You should see the same foot traffic. It's the same aisle. You know, people are in the same store. And there in the control categories, we see that from the pre-experimental baseline period to the experimental period, the difference was actually positive in terms of sales. Sales went up by 0.8 units. And so then you can form the difference in difference estimate, which is shown in bold on the right. That's taking the minus 1.3 and subtracting off the 0.8 that we saw, the 0.8 increase that we saw in the control group, to get a difference in difference of minus 2, okay? So what that implies is there was a 2-unit relative reduction in sales in the treated categories relative to a base amount of about 25, so about a 8% reduction in sales when we put these tags on, all right? Now, as we've talked about, any difference in difference comparison like this relies on the fundamental identification assumption that absent this intervention, there would have been a similar trend in the control categories and in the treatment categories. That's the assumption that we're making here. If we make that assumption, we can interpret that minus 2.1 as the causal effect of what we did. Now, a natural way to evaluate that assumption is to turn to data from the control stores. These are 2 other grocery stores where we didn't do anything, and compare sales in the same set of control categories and treated categories. And what you can see there is that in the control stores, exactly as you'd expect, there's no differential trend in sales between the treated categories and control categories. You get a difference in difference estimate of basically 0. And so what that means, that supports the assumption that there are parallel trends in the treated store, and it supports the view that, in fact, showing people this information about sales taxes does actually change the amount that they buy, and it changes the amount that they buy non-trivially, right? We're showing them sales tax of 8%. The California sales tax is around 8%. And they're reducing the amount they buy by about 8%. So it's like a elasticity of 1, essentially, in the terminology we talked about in the last lecture, which is quite large. Which basically implies that people are deviating substantially from the benchmark that this intervention should have no impact at all. In a sense, the rational model would say, we're just telling them information they already knew, this should have no impact, right? And so we seem to reject that hypothesis. So one concern you might have with this sort of approach, this sort of experimental intervention, is when you show people tags like this, we are interpreting this as the impact of giving them information about the sales taxes. But a very different interpretation is these tags are obviously quite unconventional. People are not used to seeing them. So that section of the store is going to look kind of weird relative to what you're used to. And you might say, I don't know what's going on here. Like, I'm not going to think about buying a hairbrush this time around, and I'm going to go to some other part of the store. And maybe it has nothing to do with the information we're actually showing people about sales taxes. Maybe it's some other general deterrence effect. So anytime you do an artificial intervention of this type, you worry that the impacts that you're seeing might be driven by some contamination of that sort rather than the channel that you are interested in. So in order to get at that, we conducted a second quasi-experimental study where we take a different approach. We compare the effects of 2 different types of taxes that are included in the posted price that you see on the shelf, and taxes that are not included in the posted price. And so in this particular case, we focus on alcohol because alcohol has the feature in the US that it's subject to 2 sets of taxes. There's an excise tax, which is included in the price that you see on the shelf, and then there's a sales tax like you face on other goods. And so what we're doing here is taking a quasi-experimental approach where we're not changing anything. We're just looking at observational data. And in this first chart, we're looking at the impacts of changes in the beer excise tax levied at the state level. So think about if Massachusetts raises its beer excise tax, let's say from last year to this year, it's going to be on the far right side of this chart. And if it reduces the beer excise tax, it's going to be on the left side. And we're just plotting the change in per capita beer consumption versus the change in the beer excise tax rate across states. And what you see is a very clear downward sloping relationship here. The higher the tax rate, the higher the prices consumers pay. And when prices go up, people buy less of any good, beer in this particular case. This is just showing you that the demand curve for beer slopes downward, okay? So this is a fact that was known before, and I think makes perfect intuitive sense. Now let's repeat that exercise looking at sales tax changes instead of excise tax changes. So same type of tax, but it's levied on the price, it's not shown in the price that you see on the shelf, right? And notice that the relationship here is much flatter. So you would expect these 2 things to have relatively similar effects. Why would you expect them to have similar effects? If you think about, say, substitution between buying alcohol and non-alcoholic beverages are not subject to the sales tax because food is typically exempt from sales taxes in most states. And non-alcoholic beverages are also not subject to the beer excise tax, obviously. And so you might expect the sales tax to drive the same kind of substitution pattern from alcoholic beverages to non-alcoholic beverages. But in practice, you don't see that. Sales taxes have essentially no effect on beer consumption, whereas excise taxes have a quite substantial effect, which is again consistent with the idea that people's responses to tax policy, even this very basic sales tax, not complicated at all, even that is greatly affected by salience or the visibility of the tax. So that very simple finding has since led to a much larger literature on tax salience where people have developed this much further, where there's evidence showing, for instance, that in the purchase of hybrid cars, if you give people rebates in different ways, rebates to buy a hybrid car at the time that you buy the car at the dealership, versus as part of your income tax refund a few months later, the impacts that you see on people's behavior are 10 times different. Giving people the rebate at the time of the purchase is 10 times more effective than giving them the exact same dollar value amount as an income tax refund months later. So salience really seems to matter in lots of contexts, and I think that's a key driver of how we should think about setting tax policy, something not taken into account in the traditional framework. So questions on this first application? Anyone? Okay, so I'm now going to move to a second example that gets back to income taxes and brings back some of that complexity. So let's return to the earned income tax credit, which we've talked about before. It's the largest cash transfer anti-poverty program in the United States. The EITC, we spend about $70 billion per year on the EITC, and what is one of the main goals of the earned income tax credit? Remember, it subsidizes income for low-income individuals. The reason it's structured in that way is people want to increase the incentive for low-income individuals to start working and to increase the amount they work, to pull them into the labor force. So this is a program that has tremendous bipartisan support because it both redistributes income towards the bottom of the income distribution, and I think people like the feature that it increases the amount people are working at the same time. So the question I want to focus on here is whether the EITC is actually successful in achieving the goal of increasing work. And so I'm going to talk about a paper with John Friedman and Emmanuel Saez where we study this question using a big data approach, using data from tax records, focusing specifically on the importance of knowledge and information about the EITC. So to remind you, I showed you this chart earlier. So this is what the earned income tax credit schedule looks like. So on the vertical axis is the size of the EITC credit that you get as a function of your total earnings. And you can see that if you have no earnings at all, you get no EITC. And then as you earn more, you get a bigger EITC. And then as we talked about before, at some point that caps out and then gets phased out. If you were to pick a point in the income distribution to get the biggest possible EITC refund and minimize the other taxes you have to pay, you would pick the line shown in blue for a person with one child and the line shown in red for a person with 2 or more kids. You'd pick that point that maximizes the size of the EITC refund, but then you want to be on the left side of that segment so that you pay as few other taxes as possible, Social Security tax, et cetera. Okay, so as we discussed, lots of people have figured out that this is sort of the right thing to do in order to maximize the refund that you're getting from the government. So if you just plot the distribution of income in the United States, the fraction of people who on their tax returns list various levels of income, you can see that there are spikes in the number of people who report incomes exactly at the refund maximizing level. For people with 1 kid, around $9,000. For people with 2 kids, around $12,000. So this shows you the picture just at a national level. What I want to turn to next is how these responses to the EITC vary across areas. And so to show you that, I'm going to first give you an example from Texas, where you can see a pattern that looks slightly more accentuated than what we saw in the nation as a whole. So what we're doing here is to explain how this chart is constructed. Rather than showing you the 2 separate series for people with 1 kid and 2 kids, what we've done here is just plotted income relative to that first cutoff. So going back to this chart here, we're just subtracting your actual income from the value of the dashed line, depending upon the number of kids you have. So for people with 1 kid, we're subtracting off $9,000. For people with 2 kids, we're subtracting off $12,000. And then we just lump together all the data to make it simpler to see. And so you see that in Texas, lots of people cluster right around that refund maximizing point, which is shown by 0, shown by the red line here, okay? Now, if you do the same exact exercise in Kansas, you see a very different picture. So in Kansas, people are not responding almost at all to the EITC. And so why is that surprising? It's because the EITC is a federal policy. Your incentives don't actually vary between Texas and Kansas. It's the exact same program. But somehow people are responding much more in Texas than they are in Kansas. So that's two examples. Let's generalize from that. And let's look at how responsiveness to the EITC varies across places in the United States and how it's changed over time. So I'm going to show you a series of maps that look like this. And so first, what are we plotting? We're plotting the fraction of people who report income at that EITC refund maximizing point. So the dark red here, if you look at the scale on the right, 4.1% means that 4.1% of people are exactly at that refund maximizing point to the dollar, all right? So we call it sharp bunching exactly at the refund maximizing point. In the yellow at the bottom, those would be people who are not responding at all, okay? So I'm starting out by showing you this data showing you the fraction of tax filers who are reporting income that maximizes their EITC refund in 1996. So why do we start in 1996? So one, it's a data limitation. That's the earliest point at which we have the tax data to do this analysis. But second, it also turns out to be sort of the right point to start because the EITC in its modern form, the $70 billion large program, was really expanded around 1994, 1995 under the Clinton administration to take its current structure. So you can think of this as kind of the starting point under the modern EITC. Okay, so when you look at this map, it basically looks all yellow, right? It's like across the US, people are not responding very much to the EITC. There are very few people clustered at that refund maximizing point. There are a few exceptions to that. So for instance, if you look at the southern tip of Texas, you see that the color is quite red there. Lots of people in 1996 itself are responding to the EITC shortly after the program was expanded. So what I want to do now is see how this has changed over time, looking at this data, 1996 here, 1999, 2002, 2005, 2008. You can see that this behavior seems to kind of emanate from the southern tip of Texas and spread across the United States as you see the red colors spreading, right? So more and more people across the US are starting to respond to the EITC by having a level of income that's exactly around that $12,000 range that will maximize their refund. Okay, so what might be going on, question? Sorry. What might be going on in driving these the sort of pattern that we've just seen? I think one intuitive explanation is that this is about differences in knowledge and the spread of information. So if you think about any simple model of information diffusion, you might expect to see a spatial diffusion pattern like the one that I just showed you. As more and more people learn about the EITC, they tell their neighbors, the knowledge spreads, and you start to see more and more people responding. So I think that's one plausible hypothesis. That was our hypothesis when we saw this pattern in the data. A different explanation, though, is that maybe it's about other differences in behavior across places. So some of this response that we're seeing of people reporting income that maximizes the refund is driven by non-compliance. People are basically making up income or they're reporting self-employment income to get the biggest check that they can from the government. And if you think that tax compliance or tax enforcement patterns vary across the United States, maybe it just so happens that in some places people are doing more misreporting, and in other places they're misreporting less, and that's what's driving the spatial variation. So to test between those explanations, show you how you can use quasi-experimental data to really get at this, we recognize that the knowledge explanation makes a very specific prediction. It makes the prediction that there should be an asymmetric impact of moving to a place where lots of people are responding to the EITC. So in particular, if you move to a place that is a high bunching area, a red-colored place on the map that I just showed you, like southern Texas, we would expect that if this is about learning and knowledge, you would figure out from your neighbors, there's this program called the EITC, you can get a bigger check from the government. If you have an income around 12,000, maybe I should start figuring out how to earn that much or report that level of income. So we'd expect to see a positive response there, right? But if in contrast, you make the opposite move, suppose you move from southern Texas to another place, from a red-colored area to a yellow-colored area on the map, we would expect you to remember what you already learned, and we wouldn't expect you to start responding less, right? So there should be an asymmetric impact. Moving to a more responsive place should increase responsiveness. Moving to a less responsive place should not have any effect. And so we test that explanation by looking at people who move across places. And so what we're doing here is an event study, similar to things we've talked about before, where we're looking at a set of people who move in year 0 across zip codes. And we divide them into 3 groups: people moving into the highest bunching decile, so that is moving into the reddest colored places on the map, like southern Texas, people moving into middle bunching areas, and people moving into lower bunching areas. And what you see very clearly is if you move to a place where lots of people are responding to the EITC, you yourself are much more likely to report income exactly at the refund maximizing level. So that green series, you see it immediately jumps up after you move. Whereas if you look at the others, if you're moving to a lower bunching area or a middle bunching area, there's relatively little impact. So this supports the idea that people are acquiring this knowledge when they move, in particular to these highest bunching places. Moreover, you can see directly that those impacts are highly asymmetric. So what we're doing now is on the horizontal axis, we're looking at the change in the level of responsiveness, the change in the sharp bunching rate. So plus 1% means you move to a place where 1% more people were clustered at that refund maximizing kink. Minus 1% means you move to a place where 1% fewer people were clustered at that refund maximizing kink relative to where you started. And you can see if you move to a place where more people are responding, you yourself respond more, as measured by the fact that you yourself now get a bigger EITC refund from the government. It's about 100, goes from $60 up to $120, so you get about a $60 bigger check from the government on average if you move to a place on the far right. But if you symmetrically move to a place on the far left, you make the opposite direction move, there's no impact at all. So that chart, I think, is highly consistent with the view that this is about knowledge. You would not expect other things to have this very particular asymmetric effect. But if you have knowledge, if you have a learning and memory sort of explanation, this is exactly the pattern that you'd expect to see. So our sense from this is that a lot of the variation that we're seeing in responsiveness to this program across the country is driven by the fact that people are much more knowledgeable about it in some places than others. So you might ask, what is it that's driving that variation in knowledge across places? Turns out if you look at the data, you see that the places with the highest level of responsiveness have the greatest density of EITC filers. So if you're in a place where there are lots of other low-income people claiming the earned income tax credit, that's the type of setting where we'd expect knowledge to diffuse rapidly. And those are exactly the places where we see everyone responding more. If you're in sort of a rural area or you're in an area where there are very few people who are low income, you're maybe less likely to get that information, and we see much less responsiveness there. So that's, again, consistent with the idea that knowledge and diffusion of information really affects responses to taxation. Questions on this? Anyone? Okay. So one last point on the EITC. So audit studies, so by that I mean when the federal government does audits of tax returns, which they do at random, audits reveal that sharp bunching at the EITC refund maximizing point is largely due to the misreporting of self-employment income. So that very sharp kink that we were seeing, that clustering at the refund maximizing level, is largely due to misreporting. And how do we figure that out? When we go to audit people and we try to figure out what their self-employment income actually is, and suppose we look at the income distribution that we get after the audit, where we've tried to correct any reporting issues, a lot of that big spike that we saw in the distribution completely disappears. Because a lot of the people who were reporting exactly that amount, that was not actually their true income after the audit was done. And so why do I emphasize self-employment income here? Because as some of you might know, self-employment income, if you, for instance, have a small business, or you were doing some jobs where you're not working for an employer, you basically declare your own income on your 1040 tax return, and there's no way for the government to verify whether that is actually your income. So there's a lot of scope for misreporting there. And so there's quite a bit of work showing that, in fact, lots of people misreport their self-employment income in advantageous ways. So the reason I emphasize that is showing that a tax policy changes what people report, the number they write down on their tax return. That's useful to know, but that's kind of not the core behavior that we're interested in, right? The goal of the program is not to get people to write a different number on their tax return. It's to actually get them to work more. And so in order to assess whether the program's successful on that dimension, we want to isolate real work responses. Do people actually start to work more hours, for instance, or earn more income as a result of the EITC? So how can you do that? So what we do is focus on wage earnings reported on W-2 forms directly by employers. So those of you who've held a job, you know, like for instance, my Harvard salary is directly reported to the government on Form W-2 by Harvard. So I don't really have scope to misreport my salary because the government's already getting that information directly from the university, and similarly for all employers in the US. So we have that data as well. We have the data directly from the W-2s, and we can use that as a measure of income that is not manipulated through potential misreporting, okay? And so when you look at that distribution, so if you just look at the distribution now of income based on W-2 forms, notice that there's no spike here at all. There's no evidence of a big jump in the fraction of people who have an income of exactly $10,000, which would be the refund maximizing point in this case. And so the question we want to, so one view you might have when you see this picture is, oh, it looks like the EITC actually has no impact at all on the earnings of people who are actually holding these jobs with employers. So if you leave out the self-employment margin, it seems like it's having no real wage earnings response. But I actually think that conclusion is not obvious, and I'm going to show you that in a second. So that the question we want to ask here is the EITC actually having an effect on this distribution of earnings? And the reason I think the answer to this question is not obvious is it would be very surprising if people are able to target an earning of exactly $9,700 to maximize their refunds when they're working for an employer. So think about what you'd have to do. You'd have to structure your hours at a given employer, as I've mentioned before, like Walmart or wherever you're working. You'd have to somehow structure the amount you're working so you end up earning exactly the amount that maximizes your EITC refund, which just seems implausible. You're not going to be able to make that sort of fine adjustment. And so what you can instead do is split the data up in this way, which turns out to be quite informative. So what we're doing here is we're looking at that same distribution of W-2 wage earnings, but now we're comparing places where we saw a lot of responsiveness on the self-employment margin, so the highest bunching places, so those are the places like Southern Texas, versus the places like Kansas, where we did not see a lot of people responding to the EITC in that very sharp way. So based on the logic that I was describing before, think of the places in the red as being the places where there's a lot of information about the EITC, and the places in the blue as being the places where there's relatively little information about the EITC. And what you can see, I think, is an interesting pattern, which is that there's more mass in the distribution. There are more people earning something between $10,000 and $17,000 a year in places like Southern Texas, where we see greater information, greater awareness of the EITC. So what does this show? I think this is exactly the type of response that you'd actually expect to see if people are working and earning more in response to this program in places where they know about it, right? So notice that in particular, there are fewer people with very low incomes and also fewer people with higher incomes, and more people who have decided to hold jobs that pay them something around $12,000, $13,000 a year. Now, they're not exactly hitting the $9,800 mark that would maximize their refund, but they probably can't do that. But more broadly, what the program seems to do is it shifts people to earn more in the region where the refund is maximized. And the way that you can see that is by essentially using the places where people don't have information, the blue here, as a counterfactual or sort of a control group for the places where people do have information, giving you that comparison you need to figure out what the EITC is doing. So this evidence seems to suggest that the EITC does in fact affect the amount that people are working, perhaps quite substantially, but only in the places where people are aware of the program, which I think makes perfect intuitive sense. Now, you might hesitate in drawing that conclusion just based on this simple comparison. So effectively, what are we doing in this chart? We're comparing the earnings distribution in places like Texas with the earnings distribution in places like Kansas. Now, on the face of it, as we've talked about earlier in this class, that is not a very good way to isolate the causal effect of a policy, right? Because there are lots of things that are different between Texas and Kansas. Just a simple cross-sectional comparison like that is never going to be that convincing. So here's one final piece of evidence that we found especially convincing. So you become eligible for the earned income tax credit essentially when you have your first kid. When you don't have kids, you're essentially ineligible for the EITC in the US, or you're eligible for a very small EITC. So what we did is looked at a set of people who had kids in the sample window that we were looking at, and we repeat the analysis that I was just showing you, first looking in the year before their first child was born. And we're plotting the distribution of wage earnings in places with very little information, little responsiveness, more information, and the maximum amount of information. So the same type of comparison as before. So here, notice before people have their first kid, there's no difference between these three series, right? So earnings, as you might expect, in the absence of the EITC, there's nothing to be informed about. You're not eligible for the program. They look similar in all of these places. Now look at what happens right when you have your first child. You immediately see in the higher information areas, places like Southern Texas, there are more people earning in that window that maximizes the size of their EITC refund. So I think of that as more people decide to stay in the workforce, more people try to retain a job that pays them around $15,000 a year as a result of this program in the places where they're informed about it. So I think what that shows you is that taxes do matter. They do change the amount that people work, maybe not a tremendous amount, but they're changing incentives at the bottom as the program intends in the places where there's information about it, all right? So I think that's the bottom line lesson from the second program, the second application. EITC does in fact have significant impacts on the labor supply of low-income families with kids. So it kind of works to achieve its intended goal. However, it doesn't work as well as it might because knowledge about the program seems to play a really big role in determining its impacts. And as a result, I think that if you really want to amplify the impacts of the EITC on labor supply, rather than thinking about the traditional economic debate would be instead of offering a 40% subsidy, 40 cents on the dollar from the government, maybe we should increase that to 50 cents or 60 cents to get people to work more. Rather than focusing on that, I actually think the more effective thing to do might be to figure out how you get more people to actually be aware of the program to begin with. One way to do that is sort of an informational or marketing campaign in various ways. But a different way to do that is to think about a completely different program design. Imagine that the EITC was not added to your income at the end when you file your income taxes, but suppose it was somehow actually part of your wage. So when Walmart paid you, when you get your paycheck, suppose it was just built in, that every time you earn $10, you would literally get 14. Then you kind of wouldn't even need to think about the EITC. You wouldn't have to have any awareness of the program. You'd just see a higher wage rate, and maybe that would change the amount people want to work even more. Now, that's a very difficult thing to operationalize when you have an annual income tax system, because you kind of have to keep track of how people's earnings change over the entire year to get this right. But at least as a conceptual exercise, you can see how it could potentially be quite effective. Okay, so questions on this second application before I move on? A minute. Okay. So last application. So I'm going to talk about retirement savings. So this is motivated by the fact that there's widespread concern that many families are not saving enough in general, and in particular for retirement in the US and many other countries. And so the US, in order to address that issue of undersaving, effectively spends about $100 billion per year on programs to increase savings for retirement. So what form does that take? Most of you will have heard of things like individual retirement accounts, IRAs, or 401ks, which are tax-subsidized accounts to save for retirement. So if you earn $100,000, let's say you put $10,000 of that in a 401k, you get to subtract $10,000 from your current tax bill. You only pay taxes on $90,000, and you get to put the $10,000 in the 401k and accumulate interest and capital gains without taxation. Okay, so it's a tax preference for savings. It effectively costs the government lost tax revenue of about $100 billion a year. So in that sense, we're spending about $100 billion a year on these programs. So question, is this an effective way to increase retirement saving? The goal of providing this $100 billion subsidy is to actually get people to save more. Are they actually saving more? Or are there other policy instruments that might be more effective? So this is a case where I think insights from behavioral economics have shifted policy approaches to increasing saving dramatically in the past 15 years and really changed, I think, the way economists think about these issues. So the most influential study in this literature that really kicked this off was a paper by Bridget Madrian, who was here at the Kennedy School at the time, and John Shea, where they analyzed the impacts of employer defaults on individuals' 401k retirement account contributions. So the idea here is that many employers they offer you a retirement savings plan, and some of them default you into a particular savings plan. So the default could be, unless you fill out the paperwork, you don't have any retirement savings at all, any retirement contributions at all. Or the default could be, if you don't do anything, we're going to take 2% of your paycheck or 3% of your paycheck and put it in your 401k account. Now, importantly, the only thing the default changes is whether you opt in or opt out of retirement saving. Either way, your incentives are exactly the same, right? They're not changing anything about the policy itself. It's just, is the default option that you save and then you can opt out of that if you don't want to save for retirement? Or is the default option that you don't save and then you can opt into saving for retirement if you want to, okay? So in the traditional economic model, again, where people are optimizing perfectly, the default should be totally irrelevant, right? If I tell you you've got to fill out the paperwork to opt in or opt out, it should make no difference. You face exactly the same incentives. So what they do in this paper is analyze whether that's the case. And they do that by looking at data from an employer where they have information on who's contributing to retirement accounts. And this employer switched from having no default into the retirement savings account to having a default contribution. And so this chart shows you what happens as a result of this automatic enrollment or default policy. So start by looking at the green series. So this is showing you the fraction of employees who participate in the 401k plan based on the number of years they're working at the company. So if you look at the green squares, you can see that that's gradually going up over time, where initially you have something like 20% of people sign up for the 401k. By the time you look at people who've been working at the company for 4 years, you have something like 35–40% of people signing up for the 401k. So the company then, at some point, decided to switch their policy such that everyone got automatically enrolled in the same 401k plan when they started working at the company, and they could opt out of it if they wanted to. So same incentives as the curve in green. And the result of that is shown in the orange. You can see that the fraction of people contributing to the 401k is immediately at 80% and remains at 80% throughout. So just this simple switch, opt out instead of opt in, raises the fraction of people saving for retirement from something like 20–30% to 80% without spending any money, right? And then at some point they decided to stop the automatic enrollment program. And what happened is shown in the blue. You go exactly back to what you had before. Okay, so I think that's pretty convincing evidence that the default itself has extremely large effects on whether people save for retirement or not. Moreover, it has a very large effect on how much they save for retirement. So this is now showing you the distribution of retirement savings, that is, the amount that people are contributing to these accounts. And the way they set the default at this company was that 2% of your paycheck would be put in the 401k when you were in the automatic enrollment regime. And what you can see is if you look at that orange bar that's circled there, 67% of people contribute exactly 2%, which is the thing they were defaulted into. Whereas in the other periods, when there was no default, people contributed a wide variety of different amounts, from 1%, 2%, all the way up to 6 or 7%. So what that shows you, again, is it's very consistent with a model where people are totally passive. It's like you're not paying attention at all. You have no idea if your money is being put in a retirement account or not, at what rate. You don't bother to look at all the paperwork. And so if I put 2% of your paycheck in a retirement account, you just end up going with that, and you end up having more money in your retirement account. You will have more wealth potentially when you retire. Okay, so that very simple fact is a strong challenge to the traditional optimizing view in economics, and potentially suggests a very different direction for retirement savings policy. Maybe instead of spending $100 billion a year on these incentives, maybe we could just default people into saving for retirement and potentially achieve very similar goals at much lower cost to the government. But before we jump to that conclusion, there's one additional issue we have to resolve, which is whether defaults increase total savings, or do they simply lead to shifting of assets from non-retirement accounts to retirement accounts. So what I mean by that is, if you think about the Madrian and Shea evidence that I just showed you, it shows you that people save more in their 401ks when they're defaulted into a retirement savings plan. However, it's not immediately obvious what impact that default will have on total levels of savings, both in retirement accounts and in your non-retirement bank or brokerage account. Why is that? Even if you're completely inattentive and passive the way that I was describing, at the end of the day, you still have to satisfy your budget constraint. If you earn $100,000 a year, you only have $100,000 to work with. If you didn't pay attention to the fact that $5,000 of that got put into a retirement account while you weren't looking, you now have $95,000 left, and either you can cut the amount that you consume, maybe you don't buy a new car or you buy less food or whatever, and so you end up saving, either you could cut the amount that you consume, or you could cut the amount that you're saving in other accounts. So you might have been saving $5,000 a year in your bank account, but now that you've got this retirement account contribution going, maybe you cut the amount that you're saving in your non-retirement account from $5,000 down to $0. Why is that important? Because if what the default is doing is just getting you to save more in your retirement account at the expense of less saving in your non-retirement account, we're not changing anything in terms of overall savings rates, which is the thing that we care about, right? So the evidence I've shown you so far suggests that defaults might work, but it doesn't necessarily show you yet that they change total savings. So getting at that issue is pretty hard in the United States because we don't have data that gives you information on all of people's accounts. So we don't know, we tend to know what's in your retirement account at a given employer, but we may not know what's in your brokerage account, what's in your other bank accounts. Getting all of that linked together is incredibly challenging. So we wrote a paper looking at this issue using data from Denmark, where in Denmark, because they have a wealth tax, they have a full record of all the different accounts that people have, okay? And so it's better suited to analyze this question. And so the approach that we take is we look at the impacts of defaults in Denmark, very much inspired by the Madrian and Shea work, where again, in Denmark, like in the US, employers make pension contributions on workers' behalf automatically. You have the same automatic contribution thing, but the level of the contributions vary significantly across employers. And so what we do is, again, an event study design where we look at people who switch firms. So, you can think about this simply as, suppose I switch from one university to another. Harvard might have a contribution rate of 10%, Stanford might have a contribution rate of 5%. When I move from Stanford to Harvard, does that change the amount that I'm saving in my retirement account? Does that change my total savings rate? That's the type of exercise that we're thinking about. And so what you see here, just the results are easy to see in this simple chart. So same type of setup as other event study charts we've talked about. We're talking about a set of people who switch firms in year 0 here, and they're moving to a firm that has a 3% higher or 3% or greater increase in the employer contribution, okay? And this first series that I'm plotting here shows you that mechanically, when people move to a firm where the employer is contributing more to their retirement account, they have higher employer contributions, okay? So that's kind of the treatment that's occurring. We're looking at a set of people who are moving to firms that are contributing more to their retirement accounts. Now, the key question is whether people offset that increased retirement saving by saving less in other accounts, okay? So you can look, for instance, at whether people are contributing less themselves to their own individual retirement account. So the question here is, when your employer is putting more in your 401k, do you respond as you might rationally by putting less in your own IRA, your own individual retirement account? And that red line shows you that you essentially do not offset any of that increase. When you move to an employer that's contributing more for retirement, you don't cut back on your other retirement savings. And moreover, you don't cut back on any of your other savings in other taxable accounts either. And so the consequence of what I just showed you is when you move to an employer that's contributing more for retirement, you end up having more total savings. And then we show that when you track these people over many years, you see that they have substantially more wealth accumulated for retirement. And when they retire, they're retiring with a lot more money than people who weren't defaulted into these higher retirement contribution levels. So what you can see here is, from the behavioral economics perspective, you can actually shift around a very important issue, the amount that people are saving for retirement, just by changing these automatic enrollment plans without even bothering with these tax incentives. And that, I think, is an illustration of how, as we think about tax policy, behavioral economics potentially brings new tools to the table that can be much more effective. So I'll stop there today.